What exists beyond the edge of our universe? This video will discuss 9 possibilities. Number 1. There may be countless universes outside of our own. The vast expanse of the cosmos has long been a subject of wonder and speculation. Among the most profound and intriguing theories is the idea that our universe is a single entity in a potentially infinite collection of universes. In other words, a multiverse. Delving deeper into this concept, one might envision our universe as a bubble that emerged within a different kind of space. This space could be the birthplace of numerous other universes. Each of these universes might possess distinct properties, governed by different constants of nature, leading to a multitude of cosmic variations. In such universes, stars might burn with different colors, planets could have unimaginable landscapes, and life might evolve under entirely different paradigms. These universes might even harbor forms of matter and energy that are alien to our understanding, resulting in physical realities that are starkly different from our own. The sheer number of these universes could be staggering. While we often grapple with vast numbers like quadrillions, quintillions, or sextillions, the actual count of universes might surpass even these astronomical figures. It's a humbling thought that challenges our understanding of existence and the nature of reality itself. Perhaps in the future, we could build equipment powerful and advanced enough to detect these hypothetical universes. Make sure to watch until the end, because this video explores the potential evidence of previous universes, higher dimensions of space, black hole universes, what might exist outside of our multiverse, and more. Number 2. Our universe may be infinite. The observable universe is 93 billion light-years in diameter. Some scientists estimate that the universe is at least 250 times larger than the observable universe, or at least 7 trillion light-years in diameter. If this is true, only 5% of the universe is visible. But could it be that our universe is far larger? And if the universe is considerably larger than our estimates, that could mean the universe existed a long time before the Big Bang occurred. Or perhaps our universe could only appear infinite because of its shape. Some researchers believe our universe has the shape of a closed hypersphere. If that's true, that would mean if you were to travel in a straight line through the universe, you might eventually return to your starting point, similar to how you can travel in a straight line on the surface of a sphere and eventually come back to where you started. If our universe is indeed a closed hypersphere, determining what exists outside of our universe could require unconventional approaches that we will cover shortly. Number 3. A higher dimension of space. While the idea of 3 dimensions of space and one of time is intuitive to our everyday experiences, string theory suggests that our universe is far more complex. Some versions of string theory propose the existence of up to 11 dimensions. But why don't we experience these additional dimensions? The answer lies in their nature. These extra dimensions might be compactified or curled up, so minuscule that they elude our direct perception. They exist at scales so infinitesimally small that they remain hidden from our immediate experience. Also, our universe could be a 3-dimensional brain, akin to a sheet of paper, floating within a vast, higher dimensional expanse. But how can we begin to understand or even access these higher dimensions? Some theories propose that black holes might hold the key. Black holes could potentially serve as gateways or portals to these extra dimensions. By studying the intricate properties and behaviors of black holes, scientists hope to glean insights into the nature of higher dimensional space. Number 4. Black hole universes. Perhaps one of the best ways to find out what lies beyond our universe is by studying black holes. Black holes have long been a subject of fascination and speculation among scientists and enthusiasts alike. Central to the mystery of black holes is the black hole information paradox. As matter falls into a black hole, what becomes of its information? Does it vanish, defying the laws of quantum mechanics? Some theories propose that this information isn't obliterated, but is instead imprinted on the event horizon, or perhaps even transferred to an entirely new universe. But black holes might serve another purpose, acting as wormholes. These theoretical passages through spacetime could provide shortcuts between distant points in our universe, or even serve as bridges to entirely different universes. This may be made possible by white holes, the theoretical opposites of black holes. White holes are regions in spacetime from which matter and light can emanate, but which remain impermeable from the outside. There's tantalizing speculation that the exit point of a black hole might be a white hole, disgorging all the consumed material and energy into a different universe or dimension. And what of these new universes birthed from black holes? They might not mirror our own. With entirely different laws of physics, constants, and properties, these universes could host structures and phenomena beyond our wildest imaginations. Number 5. Nothing. What if beyond the edge of our universe, there is simply nothing? The concept of nothingness is difficult to grasp. In our everyday lives, we are surrounded by matter, energy, and a myriad of stimuli. But beyond the edge of our universe, there might be an absence of all that we know. No stars, no galaxies, no dark matter, and no energy. Just a void, an infinite expanse of emptiness. This idea is not without its challenges. For one, how can we define or understand nothing? In physics, even the vacuum of space is not truly empty. It is filled with virtual particles that pop in and out of existence. But beyond our universe, there might be a realm where even these virtual particles don't exist. If there is truly nothing beyond our universe, it would mean that our universe is all there is, a finite island of existence in an infinite sea of non-existence. It would mean that our universe is not just a random bubble in a multiverse, but might be truly unique. Furthermore, the idea of nothingness beyond our universe raises deep philosophical questions. Why does our universe exist in the first place? Why is there something rather than nothing? These questions have been pondered by philosophers for centuries, and the idea of a finite universe surrounded by nothingness adds a new dimension to these age-old queries. Number 6. Evidence of previous universes. The vast expanse of the cosmos holds many mysteries, and among the most tantalizing is the possibility that remnants from previous universes linger just beyond the edge of our universe. This idea introduces the concept of cosmic archaeology. Just as archaeologists on Earth sift through ancient ruins to piece together the stories of bygone civilizations, we might one day scour the cosmos for these ancient fossils. These remnants could offer invaluable insights into the conditions, properties, and perhaps even the unique laws of physics that governed these ancestral universes. Delving deeper into the theoretical realm, brain cosmology, a concept rooted in string theory, suggests that our universe is a three-dimensional brain, adrift in a sea of higher dimensional space. These brains, vast and expansive, might occasionally collide. Such monumental collisions could give rise to new Big Bangs, birthing new universes in their wake. The evidence of these past collisions, and by extension past universes, might be lurking just beyond our ability to observe, waiting to be discovered. Furthermore, the enigmatic phenomena of dark matter and dark energy, which have long puzzled scientists, might find explanations in these remnants of bygone universes. Could it be that dark matter, that elusive substance, which seems to weakly interact with our universe, is actually a residue from a previous universe? Such a revelation would not only shed light on the nature of dark matter, but also provide a tangible link to a universe that preceded our own. Number 7. A base reality could exist outside our hypothetical simulation. The concept of our universe being a mere simulation has been a topic of fascination and debate for decades. If we were to entertain this idea, it leads us to ponder the nature of the reality that exists outside of our simulated existence. Beyond the confines of our digital realm, there could be a higher-level reality, one that operates under its own unique set of laws of physics and nature that are entirely distinct from what we know. This reality might be so advanced and complex that it transcends human comprehension, unshackled by our familiar concepts of space, time, matter, or energy. Imagine a species vastly more advanced than us, with lifespans that stretch across epochs we can't even fathom. For such beings, running simulations like ours could be commonplace. They might have created countless digital realms, each with its own set of parameters, histories, and outcomes. The purpose of our universe in this context could vary widely. Are we a mere testing ground for some grand experiment? An educational tool designed to teach these entities about certain aspects of existence? Or perhaps a form of entertainment, much like how we immerse ourselves in video games or movies, allowing these higher beings to experience a myriad of lives, challenges, and stories. But here's a twist to the narrative. What if the architects of our simulation are themselves living within a simulation? Some of these entities might be oblivious to the fact that their reality is also a construct, while others might be well aware of that possibility. The reality that might exist outside their reality might be even more complex. Perhaps there are more layers of existence than we could ever conceive. Number 8. There may be countless parallel universes. One of the most intriguing theories to emerge in recent times is the many worlds interpretation of quantum mechanics. This interpretation suggests that every quantum event spawns countless parallel universes, each representing a different outcome of that event. In essence, every decision, every chance, and every possibility that has ever existed in our reality could be playing out in another universe. The vastness of what lies beyond our universe might be so immense that there are parallel universes identical or nearly identical to ours, where every conceivable version of our history and future exists. Imagine a reality where every moment of our past, every instant of our present, and every possibility of our future is occurring simultaneously in countless other universes. The sheer scale of this concept is mind-boggling. An infinite multiverse might suggest that every conceivable event that can occur has indeed taken place or is taking place somewhere else. There could be a parallel Earth where history unfolded in an entirely different manner. Perhaps in one of these universes, dinosaurs still roam the planet, or in another, you chose a different path in life, leading to an entirely different set of experiences and outcomes. This notion challenges our understanding of time itself. If every moment is happening concurrently across an infinite number of universes, then the linear progression of time, as we understand it, might be nothing more than an illusion. Time, in the context of the entire multiverse, could be a mere construct of our limited perception, with all moments existing simultaneously in a vast cosmic web. Number 9. There may be countless multiverses and beyond. What if our universe, or our entire hypothetical multiverse, is really the size of an atom in a structure that is far larger than we can conceive? What if we live in an infinite hierarchy of multiverse structures, each nested within the other in a never-ending cascade that reaches outward indefinitely? What if beyond our hypothetical multiverse, there are systems of such diversity and strangeness that they bear no resemblance to anything we can conceive? These realms might operate on entirely different foundational rules and principles, challenging our very understanding of existence. Beyond our multiverse or even our own universe, the laws of nature might be as bewildering and unfamiliar to us as the perplexing principles of quantum mechanics. Perhaps beyond our multiverse, there are vast mathematical landscapes representing every conceivable mathematical and logical construct. Perhaps there's an infinite ocean of pure energy. However, the most humbling possibility is that whatever lies beyond our potential multiverse is so profoundly different and incomprehensible that it remains forever beyond human cognition or imagination. It's a reminder of the limits of our understanding and the infinite mysteries that the cosmos might hold. Thanks for watching. Make sure to check the description below for a free PDF and watch this next video about space.